In the last few years, we've been hearing about AI almost every other day, right? Every company in the world, literally from startups to big tech, they want to integrate AI. But the truth that most of us, almost all of us, miss is that AI needs clean, structured, and reliable data. And who actually builds these systems in order to make it happen? They are data engineers, right? So the global big data technology market size was valued at $349 billion in 2023, and it's projected to grow to $1,200 billion by 2032. Yeah. So there is no better time to become a data engineer than right now. The salaries of data engineers in the US ranges from $80,000 to over $500,000 and from 8 lakhs to over a crore in India. In this video, I will be sharing with you a complete roadmap with all of the resources that I have used in the past that you can use in order to become a strong data engineer. So if you stay till here, please watch the complete video because this is going to be the only data engineering roadmap that you're going to need. So there are 11 topics that I'm going to talk about, and they are programming language, databases, Linux, processing, which is Spark and Kafka, data modeling and data warehousing, orchestration, and in this part we have Airflow, Prefect, Dagster or Mage, cloud, and in cloud we have AWS, Azure, and GCP. We have Git, DevOps, CI/CD, and then finally projects. Right. So I understand that some of the topics for DevOps and CI/CD overlap, but don't worry too much about it, and let's get started. Now let's start with the first topic, which is programming language. So the most widely used programming language by the data engineering community is Python. And of course there are other languages like Scala, Java, but what actually makes Python the first choice is that it has a massive ecosystem and libraries for data engineering. So for example, Pandas, Airflow, Spark, Scikit-learn, and all of this, right? And it's easy and simple to write and understand. It is as if I'm writing pseudocode. Yeah. So now that being said, it's really important to understand and learn the Pythonic way of coding. Most of us actually end up writing C style code even after learning Python. And that's true for me as well because I started with C and C++. So I'm naturally wired to writing C style code, right? But what I mean to say is that one should prefer when you're writing Python code, you should prefer using list comprehension instead of loops. Use readily available functions like zip, any, all, and instead of writing if x equals true, just if x, right? So we should make sure that over time this should gradually go away, right? Writing C style code in Python should gradually go away. Now the resources that I recommend for learning Python is number one, this book, which is the Python cookbook. It's an amazing book and I have read it in bits and pieces, not each and every word and each and every page of this book. So I would recommend you to selectively pick up those parts that you need and then study those parts. The other excellent book is this one, which is Fluent Python. And this is also an amazing book which helps you understand how do you write Pythonic code. So these are two of the books, and if you're a video tutorials kind of a person, I would recommend going through Corey Schaffer's Python tutorials, right? And these are some very old but excellent tutorials, right? So it starts with the basics and then it goes into how do you set up your environments, how do you work with strings, and how do you work with files, and then goes on to exception handling, generators, f strings, decorators, and then finally about object oriented programming, right? It also covers Flask and Django. So I believe it covers Flask from video number 64 and then Django as well. You can ignore Flask and Django for now and cover all of the tutorial before Flask and Django until number 63, right? And these are really going to set your foundations very strong. Yeah. And the last resource that I would point to is from Dr. Fred Baptist, and I must say that this is one of the most in-depth tutorials on Python that I've ever pursued, right? So If you're looking for deep internals, inner workings, memory management, and all of that, right, you should pursue these four courses, the four parts over here, the part one, part two, part three, and part four. So they really go into depth, right? And you see that these are some 46 hours, 36 hours, and 35 and 22 hours long. Yeah. So if you have time and if you have interest, do pursue these four courses, and it is going to really help you master Python. Yeah. Now, once you've started to write code in Python and you're becoming comfortable with the loop, variables, the syntaxes, now for interviews, you need to get a good hang of DSA, right? Data structures and algorithms. However, not the typical software engineering type of DSA. Yeah. So the DSA topics that you need to have a grip on specifically for DE are arrays, strings, linked lists, stacks, queues, binary search, recursion, DP, simply basic 1D DP, right? And sometimes sliding window questions may creep in, right? So it's really important to keep in mind that you need to only solve easy medium questions, right? So when you're on lead code, only solve easy medium questions. Now coming over to the resources that I use for my Python DSA interview prep, the first one of it is Striver's A to Z SDE sheet, which is available on takeyouforward.org. So you can see here that I solved problems on the topics that I just mentioned, right? So I selected those topics and then filtered out the easy medium problems over here and then simply solve them, right? All of this is free of cost, so you can also go ahead and use this, and thanks to Striver for still keeping it free of cost. The next one that I used is LeetCode. So I again filtered easy medium problems on LeetCode and solved those problems here. The last resource that I used during my initial days in order to strengthen my DSA foundations was My Code School. And again, this is a really amazing channel because the way things have been explained, it's really simple to understand. So things like linked list, stacks, queues, and all of this, right? And even recursion. So there is a playlist on recursion, I believe, as well. Yes, so you see there's a playlist on recursion. And if you don't understand things like time complexity, you can go through this playlist. And trust me, it's really been made simple to understand. Complex things made simple. Yeah. So I would suggest that you can refer to this and then supplement this with some resources online, because the code that has been written is not in Python, it's in C++, right? So understand what's being taught, supplement it with resources online, or even use ChatGPT to get a Python working code. Yeah. All right, a quick pause before we dive deeper into the data engineering roadmap. I want to give a shout out to DataCamp, who is sponsoring this video. If you're serious about breaking into data engineering and need hands-on experience in the right skills, and honestly, DataCamp is where I myself started years ago when I was learning PySpark and SQL. So what I feel really sets DataCamp apart is the interactive learning. You code directly in the browser and get instant feedback, and you don't need to worry about installing tools locally, right? And if you're looking for a structured path, right, a structured path, check out the Associate Data Engineer in SQL track. It covers everything from SQL fundamentals to joins, aggregation, subqueries, database design, and even data visualization, right? All in one place. Plus, together with this, you'll also work through real world projects, which is again very important for building your confidence and applying what you learn. And when you're ready, DataCamp offers an industry recognized data engineer certification, which you can add to your LinkedIn and your resume. Now, the best part is that your subscription is going to give you access to everything, right? Everything on the platform, be it SQL, Python, Cloud, Spark, Airflow, or machine learning, so that you can explore and upskill however you want. I've been recommending DataCamp for years because I really find it practical and flexible. Check out the link in the description to get started. Now let's get back to the roadmap. Now let's talk about databases. And for databases, you need to have a really strong grip on relational and non-relational databases. Yeah. Relational being the more important one. For non-relational, just pick up one NoSQL database of your choice, let's say MongoDB or whichever one you've worked in the past. Understand the difference between SQL and NoSQL, and when exactly would you use either of them for which use case. Yeah. Now, coming back to relational, DBMS concepts are really a must to understand, right? And here I'm not just talking about SQL. These are database concepts, right? So things like what are asset properties, what are primary keys, surrogate keys, foreign keys, what is normalization, denormalization, OLAP versus OLTP, optimization strategies like indexing, partitioning, and all of that, right? Once you're good with that, now let's come to SQL. SQL is a non-negotiable subject, and there literally cannot be a DE interview without a SQL round, right? So your data is stored in databases, and in order to talk to databases, you need to understand the language, and this language is none other than SQL. So take up any database, be it Postgres, SQL Server, or MySQL, and start writing SQL queries. The difference in dialect between Postgres or SQL Server or MySQL is not going to be huge. So if you are comfortable in one dialect, you'll be comfortable in the other as well, right? It won't take you a lot of time. What you actually need to master is how to write select queries, how to write joins, group by, aggregation, filters, CTEs, and then going on to advanced advanced concepts and functions, which is window functions, subqueries, case when clause, and how do you use a case when clause inside an aggregation? How do you use case when inside a sum or an average? And trust me, interview questions are flooded with these type of patterns, right? So once you're comfortable with all of this, you know how to write select queries, do joins, group by, and all of that, how to use CTs, start practicing as many questions on lead code and start a scratch, right? It's really important for you before you start appearing for interviews. It's really important that you become comfortable solving medium hard SQL problems, right? So remember, easy, medium, DSA problem, but medium hard SQL problem. Now coming over to the resources for DBMS and SQL preparation, this is a really good one on Code Help specifically for DBMS, right? And they cover important topics like normalization, asset properties and transactions, atomicity implementation, indexing, how indexing works in DBMS, NoSQL versus SQL, something that I was just talking about, and then optimization strategies like partitioning, indexing, and all of that, right? It's a long video, but it really sets your foundation right. Now, coming over to SQL, I really like this one on Data with Bada, the SQL full course, because he explains it with diagrams and explains how things look like visually over here and then codifies them. Yeah. And the last one is Ankit Bansal. So his playlist on SQL interview questions are really nice. So these playlists are some of the ones: complex SQL question for interview preparation, the lead code SQL hard problems, and SQL medium complex interview problems. These are some of the ones that you can refer. Now, once you're good, you need to solve as many problems as possible, right? And in order to solve problems, these are the two platforms that I have referred to. And basically, you can select SQL problems over here, sort them, pick them by topic and by companies, right? And similarly, you would do that over here. Basically, select database and then solve the problems over here, right? So this should give you confidence in order to appear for interviews. Make sure that you're comfortable solving medium hard problems on lead code and starter scratch before you start appearing for interviews. Now the next thing is Linux, and I wanted to specifically mention Linux because all of the underlying systems and tools, be it Spark, Airflow, or Flink, they run on Linux under the hood. Our production systems are on Linux. So that is why it's very important for you to be comfortable with a lot of things on Linux, right? So for example, navigating the file system in Linux, so giving permission to files and folders, being able to monitor resources, right? Using top, htop to be able to write scripts and schedule your cron jobs. to be able to parse a text file or to be able to download files or query an API. Right. The only resource that I would like to recommend for Linux is this one, Linux slash Mac tutorials by Corey Schaffer again. And he really goes in depth into a lot of things such as navigating your file system, how to create, copy, move files and folders, how to use the find command, how do you deal with patterns using the grep command, how do you search files and directories, right? And I was talking about API. So how do you use the curl command? Yeah. So you can go through this playlist, and this is a really interesting and in-depth tutorial about Linux, right? Now the next topic is processing, and I'm going to specifically talk about Spark and Kafka. When you have big data, all of that processing is going to happen using Spark, and it is really the bread and butter for all data engineers. So learning Spark is going to help you strengthen your distributed computing concepts. So you need to learn about things like the Spark architecture, about the master and the workers, and how communication happens between the two of them, about memory management, what are jobs, stages, and tasks, optimization techniques like partitioning, bucketing, to be able to tune your Spark job, decide things like the number of executors, the amount of RAM, and the number of cores that you need to deploy, and finally become comfortable, really comfortable in writing Spark code using Spark data. The resources that I recommend for learning Spark is number one, this book, Spark, the Definitive Guide. This is really a very important and interesting book. Another important one is High Performance Spark. Unfortunately, I don't have the hard copy, but it is also a really interesting and important one. And if you're a video tutorial person, you can refer to my playlist, The Ultimate Guide to Apache Spark, where I talk about starting right from the query plans, the DAGs, going deep into memory management, and then optimization techniques, right? Optimization techniques like caching, broadcast join, AQE, dynamic partition pruning, and so on. Another course that I did on Udemy long time back, but I found it really nice, is this one, Teaming Big Data with Apache Spark. So I think this course got updated, but yeah, this is the one that I did and I found out to be helpful. Now, let's say you're working at Netflix and your use case is to track the activity of every user. Basically, where did the user click, which movie did he or she like, and what are the movies that were downloaded, right? All of this interaction can be collected through Kafka into our processing and storage system. The resources that I referred for learning Kafka are mostly two of them. The first one is this book, Kafka, The Definitive Guide by O'Reilly. It's a nice book. And the second one is this course, Apache Kafka series. There are other courses by Stephen Marek as well. So do take a look if you're interested. And it actually goes into depth. It starts with the basic and then goes into depth. And there is also a project to get your hands dirty. So these are the two things that I started with in order to gain an understanding about Kafka. Now, the next topic is data modeling and data warehousing. Now, once all of the processing has happened and your data gradually starts to flow into the lake house or the data warehouse, we need to be able to model this data, right? To be able to answer business questions. So if you're building a data model for a company like Uber, your data model would essentially contain entities like trips, payments, reviews, riders, drivers, and discounts, and many more, right? And again, all of this so that we are able to answer business questions. And how could some of these business questions look like? So some of them could be percentage of canceled rides in a day, or maybe the month on month revenue, and so on. Yeah. So I would suggest to simply start with the Kimball Data Warehousing Toolkit book. It's an excellent book, but you always used to find it difficult understanding the language of the book. If you're able to understand it in one go, excellent. Yeah, please go ahead and read the first three chapters of the book. But if you're facing difficulties similar to how I used to face as well, I always used to supplement it with resources online. So I picked up vocabulary terms like let's say surrogate keys or slowly changing dimension, and then look for resources online where I could understand them better, or maybe ask my silly question to ChatGPT and ask it to explain it with an easy to understand example whenever I didn't understand a concept. So you could follow a similar approach. And an important thing to keep in mind is at this moment, don't worry too much about Kimball versus Inman versus Data Vault or one big table. Yeah, let's first get comfortable with the Kimball approach. Let's first get comfortable with star schemas, snowflake schemas, right? With facts and dimensions, slowly changing dimensions, and then gradually you would be able to relate it with other approaches, their pros and cons, and basically which one best fits which use case. So you'll be able to gradually find that out. But let's first focus on reading the Kimball Data Warehousing Toolkit book. Now let's come over to the next topic, which is orchestration, right? So once we've written our code and our pipelines are ready, we want to be able to schedule them. Basically, we want them to run at a particular cadence on its own. And there will be cases where one pipeline is dependent on the other pipeline, or one pipeline is dependent on several other pipelines. So we want to be able to manage and visualize those complex dependencies, right? Another set of features that we could expect is when our pipelines fail, we want them to be able to automatically retry. We want to retry for 3 times or 5 times, and if it still continues to fail, it should send us an alert with the stack trace, right? So at a high level, our goal and objective is to have complete visibility over all of these pipelines. How many pipelines do we have? What is the total time taken for all of these pipelines to run, how many failed and how many succeeded, right? So this is where orchestration comes in, and there are several tools that can help us with orchestration, out of which Airflow being the most popular and the most widely used one. So I've also tried tools like Prefect, Mage, and Daxter, and they are excellent tools as well. But if you're just getting started, I would recommend Airflow because there are tons of tutorial available on the internet, and there is also a wide community. So if you're stuck, you'll be able to find more resources to resolve your issues. The only resource that I would recommend for orchestration is this one on Udemy, which is Apache Airflow, the hand-on guide by Mark Lamberty. So he really goes into depth in order to explain important Airflow features. And the good thing about it is that you get to do an end-to-end project where you'll understand how to work with things like tasks and DAGs and so on. Yeah. And just in case you're interested, you can also pursue the Airflow certification, which is these two, the Airflow fundamentals and the DAG authoring certification. Of course, these are not free. You would need to pay an amount in order to appear for the test and get the certification, right? Now, let's talk about the next important topic, which is cloud. So, all of our data is stored in the cloud. Our infrastructure is on the cloud, pipelines run on the cloud, and therefore it's really important to learn cloud for data engineering. Yeah, so you can pick up any of the cloud providers, either of AWS, Azure, or GCP. This is because for all of the services in one cloud provider, you will be able to map it to an equivalent service on another cloud provider, right? So one example of that could be ADLS on Azure would map to S3 on AWS, right? Now, despite having said that, my recommendation would be to pick up Azure because they've really been putting efforts into building services for data engineering. Microsoft Fabric is one example, ADF is another example. Databricks is a first party service on Azure, and there are many jobs specifically looking for an Azure data engineer. Yeah. So before you get your hands dirty with data engineering specific services on these platforms, I would suggest you to understand the basics, things like VMs, EC2, IAM services like IAM for permissioning and access controls, things like security groups, things like CloudWatch for logging, and similar services on other cloud providers. So these are really going to set your foundations right. Coming over to the resources, To be honest, I don't have a lot of recommendation here because I learn things on the go by getting my hands dirty simply by logging onto an AWS console, creating buckets, spinning up clusters. Of course, I've also wasted a lot of money here and there spinning up clusters and not terminating them at the right time. So I've been through that. However, what I would suggest is that if you're interested, you can go for certain certifications, such as the solutions architect certification or the data engineer certification from AWS and Azure. So with this, you would at least know what are the services to use, which services would be used in which use cases. Now, of course, I don't expect you to become a master after passing the certification. That is going to happen on the job, on the go when you get your hands dirty. But this at least gives you an idea about the services, which one you should use in which kind of scenarios. Yeah. Now, the next topic on the roadmap is Git. So, wherever you work, code is maintained and version controlled in providers like GitHub, GitLab, and Bitbucket. So, companies mostly use Git because it's really important for tracking different versions of code, collaborating with other team members, reviewing code, enabling CI/CD, and for several other reasons. Yeah. So, therefore, is really crucial for you to understand how Git works, how you can pull code, how you can push code, basically do things like resolving merge conflicts and collaborate with other team members. More importantly, if you have a really good portfolio in Git, that speaks tons of things about you in front of recruiters and in front of people who want to hire you. So whenever you're doing a personal project, push it on Git, make it live on Git, create a good README file, create a good architecture diagram. So you can always repoint these projects on your resume and on your LinkedIn profile. So this, again, stressing on that, this shows a good number of things about you. It basically helps that you're not just a coder who knows Python and SQL, but you're an engineer who knows how to collaborate with people, and you're aware about how code is developed and maintained in the industry. Two resources that I really want to recommend for learning Git. The first one is Complete Git and GitHub Tutorial by Kunal. And he really makes it interesting by relating with some real life examples, which I really find interesting. So that's one. And the second one is by Bogdan. So this is a long 11-hour course, but if you really want to explore and deep dive into the internals and how things work behind the scenes, this is a must do for anyone. Yeah. So if you've time, do spend your hours into complete this tutorial. Now let's talk about the next topic, which is CI/CD. Whenever we want to merge a new change into our existing working code, so let's say somebody wrote up a new feature and we want to merge that feature into our existing working code, we want to be confident that on merging this code nothing breaks, right? And that is where CI/CD comes into picture. So CI/CD is going to automate the testing and validation that is going to happen every time new code is going to be merged, right? So it is going to run all of those tests, run all the validation, and ensure that only working code gets merged and deployed, right? And this is quite fundamental to every concept within data engineering. We don't want buggy SQL or buggy pipelines or buggy Airflow tags or DBT models to get merged into existing working code. Yeah. So there are several tools that are used for CI/CD. Some of them are Jenkins, Circle CI, Travis CI, GitHub Actions, and so on. On the resources, I would suggest you to take up any video on YouTube specific to, let's say, Circle CI, Travis CI, or GitHub Actions, whichever one you find easy, and try to integrate it with your projects. We'll be talking about projects in a lot of detail going ahead in the video. So make sure you watch the complete video. So try to integrate it with your projects, try to write some unit tests and see how they run whenever you want to merge a branch, right? So let's say you have a feature branch, you want to merge it to main or dev. Those tests are going to run when the merge happens, right? So try to simulate these scenarios in order to get a hang of how CI/CD works. Now let's talk about DevOps. And I would classify this in the advanced category of topics. So only start with this once you're good with all of the other topics that we've discussed until now. Yeah. So many times data engineers are not just the ones writing Python or SQL code or just writing and building pipelines. They also need to deploy and maintain those pipelines, right? And that is where the ops aspects of things come in picture. So either data engineers themselves do the deployment and maintenance, or they are coupled with infra engineers with whom they collaborate and try to understand on what are the resources that need to be created, what are the sizes of those resources that need to be created, for example, the sizes of clusters and so on. Yeah. So the best practice is to code up the infra. So for example, if you're spinning up an EMR cluster or creating an S3 bucket, rather than just going to the AWS console or the Azure console and clicking and creating those resources, this is where IAC, infrastructure as code, and tools like Terraform and CloudFormation come in, right? So all of these resources are coded up, hardened, and deployed via Terraform or CloudFormation. Yeah. So it's like being a full stack data engineer who just doesn't know how to build pipelines, but also knows how to deploy, monitor, and maintain them. Yeah. So for DevOps, I would specifically stress on three things. Number one is Terraform. Number two is Docker. And the third one is CI/CD, which I already talked about. Now, coming to the resources specifically for Terraform and Docker, I found this really helpful, which is this one on Udemy, HashiCorp Certified Terraform Associate by Zilvora. This is specifically aimed towards passing the Terraform Associate certification, but I found it really helpful and the explanation was really good. So you can purchase this and don't worry too much about the cost because if you find the Udemy sale, you'll probably be able to find this in either 449 or 549 Indian rupees. Yeah. The second one was this one by Stephen Grider. It's an excellent course. He really goes into a lot of depth, and I believe there is a project. Yeah. So there is a project in which he creates a production grade workflow. So this is really good for learning Docker, and you can skip Kubernetes, or if you're interested, you can also pursue that one. But yeah, these two are my go-to resources for learning Docker and Terraform. Now, coming to the last and one of the most important part of the roadmap, which is projects. So none of the courses, tutorials, documentation is going to matter if you cannot put all of the things that you've learned to build something meaningful, right? So go ahead, take up the AWS, Azure, GCP, or Databricks free credits, build up something that is meaningful, build a project that is meaningful. Remember, at this point, it's not important to build a project that is flashy or cool looking, but something that incorporates all of the things that you've learned. So basically, whatever you've learned, you're able to apply all of that, right? So I'm going to share with you some resources that you can use in order to get guidance and implement excellent projects, right? So the way I prefer doing it is instead of simply following line by line through tutorials, I prefer picking up GitHub repository and then try to understand the architecture and basically plug and play with the tools or concept that I want to learn. So this is one example. This is one excellent project from Data Talks Club, and this is a part of their data engineering Zoom camp. So here you'll find all of the details about the architecture right here, and then there are details about the data sets, what is the dashboard that you'll be building, and then there is also a how to, so you can watch this video and basically understand how to go ahead and implement this project, right? The other one is this one, which I found really helpful, where we are building something like this. We are extracting some data from an API and then doing the normal ETL, loading it into a warehouse, and then building a dashboard on top of it. And again, we have all of the code that you can use to implement, and whenever you're stuck, you can have a look at the code, right? Another one which I found helpful is this one, where we are basically pulling in real-time events and then doing some kind of stream processing, putting the data on Google Cloud Storage, doing some transformation using dbt, and then putting all of it back on BigQuery. All of this is orchestrated on Airflow, and then the resources are built using Terraform. And you can have a look at the code over here. Yeah. So the end result of this is this amazing dashboard. Yeah. Another one is this one, wherein we build a Goodreads data pipeline. We put all of this into S3, and then the processing happens using EMR cluster. The data is then dumped into Redshift, and all of this is orchestrated in Airflow, right? And this one is a list of projects, basically from the least to most complex, and you can click on this one and see what has been built, right? So these are some of the GitHub repositories that I have found helpful, and you can also refer to them to get ideas, or maybe implement exactly the same thing with a little bit of changes here and there to get your understanding right. Yeah. And if you're more of a video tutorial kind of a person, then I would recommend Darshil Parmar's playlist, this one, 5 end-to-end data engineering projects. And then there is another channel which I find really interesting is Code with You, and there are a lot of projects over here, right? But what you can pick is this one, the Reddit data engineering pipeline, and all of this has been built on AWS. The other one is this one, building robust data pipeline for modern data engineering, right? Basically he uses dbt, Databricks, and all of that, right? So there are a ton of resources available, and if you're able to use it wisely, you'll be able to build a very strong portfolio for yourself. So it's great to see that we've now reached the end of the roadmap, and I would like to take a moment to say that if you're able to follow this roadmap with complete devotion and patience, and I particularly mention patience because I understand that this is a long roadmap, right? And it is going to take time to complete, but nothing worthwhile ever came that easy, isn't it? So I can assure you that if you follow this roadmap with devotion and patience, it will help you become a very strong data engineer. So I hope you found this video helpful, and if you really did, please don't forget to like and share this video and subscribe to my YouTube channel. So I've seen that 70% of my viewers have not yet subscribed to my channel. So please go ahead and hit that subscribe button, because it really motivates me to put out more content. Yeah. So if you have any questions, let me know in the comments, or feel free to drop me a message on LinkedIn or send me an email on afaq.ahmad@theseniord.com. Thank you very much for watching.